Dr. Justin quickly. Dr. Justin John is the director of the Big Data Hub, as well as the director of ILab. This is the interdisciplinary research institute at the University of Nevada, Las Vegas. He has been a faculty member at North Carolina A&T State University and Carnegie Mellon University. His research interests include big data, information assurance, social computing, biomedical computing, and health information. He has been the steering chair of the International Conference on Social Computing and the International Conference on Privacy, Security, Risk, and Trust. He has been the editor-in-chief of the International Journal of the Mathematics and Statistics, the International Journal of Privacy, Security, and Integrity, and the International Journal of Social Computing, and the Cyber-Physical System. In the recent years, he has published more than 200 articles in peer-reviewed journals and the conferences, and delivered about 13 keynote speeches and elect talks. His research has been extensively funded by National Science Foundation, Department of Defense, and the National Institute of Health in the United States. So, that's a big hand to welcome Dr. Justin to deliver this talk. Thank you. Please.
Thank you. Thank you very much for the introduction. And my name is, can you see me? I do, like Dr. Phil. And my name is Justin John, and I joined UNLV, University of Nevada, Las Vegas, and from North Carolina 1 month ago, 1.5 months ago actually. I just newly joined there. And Professor Hong asked me the first question when I came here, hey Justin, why did you join UNLV? It seems a lot of gambling there. You like gambling? And so that's a part of the reason I have a family reason to join there. But meanwhile, on the research side, as I mentioned, Las Vegas is a very unique place, and it's the world's largest casino gambling place, and they have the largest hotel rooms in the world. So I'm doing the big data research, and they can provide data to me. So that's a potential good reason for the research and transition from there. So I'm joining there. Another reason is part of the research I'm doing is related to medical, and now I'm as a colleague for the Nevada Institute of Personalized Medicine, and that part has helped me quite a bit for involving the healthcare and medical research as well. All right, so at UNLV, and the first job, and since I moved there in past 1.5 months, is meeting, keep meetings. There's so many casino companies, hotel companies. They do want to use a big data approach to improve their revenue and customer service as well. And so I have been meeting with them quite a bit, and because it's one of the largest local university that's UNLV located in Las Vegas, so they like to collaborate with us, and they like to share the data in certain ways so that we can collaborate, help them to improve their revenue. So another thing, and we have a newly funded project from National Science Foundation called the Big Data Hub. And the purpose of build the Big Data Hub is trying to leverage those different missions that we have. One of the big missions that we should have is we have to leverage and the different colleges on campus and cross campus for the collaboration doing the big data research. So that's another task I have been doing, and by the part of meetings we have. So we promote dramatically and cross department, cross college collaboration. And on Big Data Hub, we just started, then we have 7 colleges on board already. So it's college actually, and they are seeking a way to do the research linked to the big data. For example, last Friday, if I fly here, we had a meeting with a whole bunch of faculty from the College of Public Health. And they do a lot of research on healthcare. They actually have a lot of data that's available that they collected from different sources. And they like to collaborate with computer scientists to really help them to analyze the data using the big data analytics approach and so on. So that's a niche that need each other for the collaboration. Later on, we mentioned another part of the research goal that we have is build up a big data repository. Well, we're doing big data research, right? I guess a lot of people here doing some big data related research as well. So when we're doing the big data research, I think one of the challenges I met is data. I claim I'm the data scientist and doing big data research, but I don't have enough data to really claim to do a big data research. Then that's a dilemma, and that's embarrassing. And so that's one part, and we found by collaborating with casino company, hotel companies, and also other colleges. And we are seeking data, but after talking with, for example, College of Public Health, they actually collect a lot of data from different sources, different projects. They want a place to host those data, and so that they can have, for example, say, big data hub, and this topic is great. Okay, we can contribute our data, can stay there so that we can save for the future for research purposes. So actually, there's a lot of data available there, but we do not know. Okay, so this is another thing I found is very useful to build the big data hub. Well, I say welcome to University of Nevada, Las Vegas. Short name is UNLV. And when I joined here, I missed one big symposium that's hosted by Nevada Institute of Personal Medicine. So a lot of companies, and I think almost 50 companies, their chief executives, will join the symposium. And that's why my dean, so you better not leave in this time. But I have to give in this talk and join this conference here. And one mission that they said, well, since you will travel there, you can promote our university. And that's one of the jobs you can do, help the university. So for the collaboration, one of the things I found from UNLV since I moved here is they were open for collaboration. And we hire more new interdisciplinary faculties and professors, and visiting research scientists, postdocs, and PhD or graduate student. And also we have this interdisciplinary education program, for example, data science program we started, and follow the data science institute program we started. So that's all different opportunities and provided for me and for other researchers and for anybody from here who want to collaborate with us. And in the good sense, we have the sponsors. And the casino companies, the gaming corporations, they made a lot of money from the travelers from the world. Therefore, they donate quite a bit of money to contribute to the research. They're happy about it because we're trying to help them to find the results. Research results will be utilized for them to improve their customer service and the revenue. But meanwhile, they donate the money to us, they save a lot of tax. They have to report tax anyway, so in that way, it's good for them too. So big data and casino, that's Las Vegas. And so right now, and a lot of the casino company, gaming companies, is really want to jump into the big data and the area to try to help improve their service, improve their revenues, and different aspects. So let me maybe play a video. Give one of the chief executives from one of the casino companies. That's by Tarek. And so basically leverage the, you cannot see it.
Obviously plays a strong role in the casino industry for obvious reasons. And it's fairly intuitive that if you have a bad experience, if you come in, you roll the dice once, and you lose all your money, that you're not going to be happy to come back. And so we've known that, and we've done things historically to action that. So if you lose in a single trip faster, significantly faster than you should, the you'll often have someone approach you on the casino floor and offer to buy you dinner, offer to give you tickets to the casino youngster or whatever it is, just to make your experience last longer so you feel like you have more value.
So if anyone has nothing to do with the shock, oh man, it's my first time in Vegas, and I
On the contrary, they may you even have to see it in the data, exactly. So you can't do that. This is all triggered off of the data that we see in the slot machine today. So you need the slot machine to get it for you. But what we noticed in the data was that small losses that we thought, frankly, were not readily visible to customers, but over a longer period of time. So not one trip, but 10 trips. If you see someone who is, and we've got ways of quantifying luck, but 10% unlucky, so not significantly unlucky, over a sustained number of trips, that those people are actually significantly more likely to defect one of my competitors that they are to stay with you. And so you can start to action that, you can start to message it, but the thing you don't want to do is follow up and say, hey buddy, I see you've been unlucky, come on back, right? So we have to, you have to think carefully about how you actually make it.
So this is one of the officers from the Caesars and gaming company talking about how they try to use a big data approach to improve their customer service and revenues. And one of the company we already started talking about the Scientific Game. That's one of the largest casino company in Las Vegas. Temporary stop here. Okay, so you can say it's a lot of companies, casino companies in Las Vegas, they are seeking way to improve their revenues, improve the customer service. And they claim they're trying to, like this guy's claiming trying to improve the customer experience so that you can come back again. Why they want to come back again? Because they want to make more money, right? So they try to increase overall their revenues and by using big data approach. We're talking with them, what's the data they collected from slot machine that they collect every day and from all and customers from all around the world. Quite a bit of data every day collected. But when we're talking to them, they actually use up to, they claim up to 1% of the data they have. Let's assume they take maximum, they utilize 1%. So 99% data is sitting there, they don't use it. But this data is become a driving force and for economy growth. So therefore, they look at this, they fund this. They see this is a very important direction to help them to further improve the revenue for casino companies. That's one of the reasons I moved there, and because at least I can contribute in a certain way to help them. And other aspect at Las Vegas is hotel management, hotel service. If you notice that the Las Vegas have a largest number of hotel rooms in the world. So they provide pretty much very good service and for hotels. Plus, a lot of travelers, they come to here, come to Las Vegas for gambling and casinos, and they have to have a place to stay, okay? So the hotels have actually very good business. I just moved to Las Vegas, and my home is still under renovation, and so some days I have to stay in hotels. Then, you know what? When I book the hotel same day for the same night, there's so many, they have largest number of hotel rooms in the world, right? It's all full. I couldn't. So sometimes I stay my friend's house for a night when they do the renovation, and sometimes. So you can say, so even they have the largest number of hotel rooms, a lot of people, a lot of need in there. But it implies what? It implies they have a lot of data. They have a lot of data collected from hotel management. So we have a hotel college at UNLV. They get a lot of data from the hotels, local hotels. So that helps for the big data research as well. Okay. Other thing that we have been doing and on plan to do, and some are already done, and some is planning to do, is follow the Internet of Things and kind of smart and smart services, smart computing, smart system, smart home, and smart education. Everything has become more smart. So this strong in these technologies and trend that we are collaborating from different programs and trying to develop different facilities. For example, right now, and from National Science Foundation, they have a smart home program. We have been discussed this back to 5-6 years ago, but now they officially invested quite a bit of money for smart homes. And so this is a thing that's we also involved. But this is not from computer science. This is computer science only part of that, trying to help the urban development and partially data analytics. But a lot of collaborations going on from different colleges. Data science program, the UNRV was brought me there in trying to start the data science program. And data science, and certainly is multidisciplinary, okay? So it's involving different aspects of research. So for example, let's just list some of this using model a graph from internet. And let's see here, how many people doing machine learning research or machine learning field? Any people doing machine learning? Yes, some machine learning, right? Anybody doing AI, artificial intelligence? Quite a bit. And anybody doing database? Database, I know privacy, that's part of you out there, okay? And statistics, visualization, anybody doing visualization? Okay, so you can say this is the only parcel of the areas we need for data science program. But certainly need a lot of input from all different experts in different domains. So I put here what this means for a data scientist. And nowadays, and a lot of companies starting hire people not called computer scientists, it's called data scientists. Okay, they need more data science. For example, casino company right now they're starting and create a job and advertisement to hire people. They call data scientists. We hire data scientists. So you're not necessarily graduate from computer science. You can graduate from statistics and other department, but you have a strong so-called data and science perspective. Then it's called data scientist. So what that means? That maybe means understand economics or mathematics of data, and or could be developing different methodologies or cognitive tools for data analytics. So we have, and it's called the supercomputing centers there, and that's our data processing. Well, we're talking about big data and data science. Well, one of the things, and we have to have a certain qualified hardware facility to help the data analytics. So we have a one of the system was donated by a big company called Switch, and it's an international company. And they headquartered Las Vegas. They donate the supercomputing cycles for us. So that can basically cluster and aggregate and peaking compute time can exceed 1,000 teraflops. And they provide to us is 1.2 EB of subsystem disk. So far I think we can use this for 2 or 3 years. And with the cycle data increasing, then the big data and report we're trying to build may need more later on. But right now, it's good for us. Okay. So next, I want to mention some of the projects funded in the past 3 years and from different funding agencies. So first one in big data related areas. One is called the future state behavior prediction and data readiness level. So this was funded by National Security Agency, and they invested $62 million for 5 years, and for doing big data research to help and come up with approach to analyze National Security Agency of the United States data. Basically, NSA, National Security Agency, they collect daily all the different network behavior data quite a bit. They never disclose to us how much they have, but they have a privilege in the United States to monitor any behavior we have. And we got a student, and he is trying to go to the Department of Homeland Security kind of job. They have to get a clearance before getting the job. He interviewed well and trying to get a clearance for it. And then they use SICAN and all the different past behaviors and on the internet and trying to see what your behavior past and to evaluate whether you are qualified for the clearance or not. So you can imagine they have a huge amount of data that's efficient. Now, if they have and a reasonable amount of data, they may have facilities or approach to analyze and precisely. But with this stage, the big data and the data they accumulated in their database and dramatically increasing every day, they are facing fundamental challenge. How do they use the data effectively for protection of the United States? So they provide approach is called the future state behavior predictions. We try and understand the performance and improve the performance analysis, and we try and developing the methodologies or cognitive tools that's for big data analytics that provides National Security Agency. So it's interesting because of security reason, the NSC have a policy they cannot give the original data to anybody. Okay, even we are the non-profit university, they know they do research purposes. That's valid. The national security policy cannot give to us. But since they invested quite a bit of money for us to do research, we can use other data that we can plug it to research. But eventually, maybe they'll be far away from the data they have. So the idea, if we can get their data, that'd be best for their purpose. And fortunately, they provide data to us through a NSA data simulator. And before I do research with NSA, I didn't know such tools exist. But NSA does has a data simulator. What they do is they have original data, then they use their data simulator to provide a simulated version of data, so we can use the simulated data for the research purpose. Now, when we do this kind of research, then getting we call maybe good result, and then how they use the approach we develop for the NSA purpose. What they do is they will take our approach that's tested on the simulated data and perform very well. They take back, then they have their research stuff, then transform, I don't know how they transform, to the actual data they have and testing on that. So that's a process, that's a project we have been doing with NSA. It's a very unique situation that they have a lot of data, but they cannot give to you. Okay. So here is a 5 university collaborations, and that's involving a lot of aspects. And I'm leading and data readiness level, and this is a pure new research. When we started this, and 3 years ago, there's no data readiness level concept. And when we started searching Google, there's nothing exist. So we have to create our own, develop pure and the first framework, and to calculate or deal with the data readiness level and for NSA data. Then you can list in the system here. You can list the different narrative processing, analytic workflows, and mathematical models and cognitive processing. All this you can say that's certainly not computer scientists can do it. There's a lot of psychology people, different other people are involved for the project. So what I want to say a little bit more details about data readiness level, and it's called DRL. So basic definition that we give in, and data readiness level when we start doing research, such term does not exist. We do not know how we call it, but basically NSA side, well, you guys developed and some techniques and provide to NSA eventually. And then we want to know, for example, we have so much data and it's ongoing, and we want to know how do I quantify the matureness of the data to answer certain questions. Then by understanding what they're trying to do, and we call a term called data readiness. Basically means how ready the data are to address the question you're trying to address. Okay, that could be means NSA data could be in different places, different domains. So that is the original term we provided and proposed. So basically, what is DRL? And when we started to give a definition, it's kind of formalism used to optimize the workflow process that involves a objectives. You must have objectives. Okay. Otherwise, the data writing level does not make sense. Then you have a data. Then you have a different analytic approach. Okay. So this is a fundamental requirement we think component we needed for data writing level computation. So let's take some examples here. Let's assume it's the person vision. Let's assume this is objective we have in the medical field. And then we have the called global readiness level. That's basically overall process. How ready the data to answer the objective question overall. Okay? And then we also have a local readiness because in order to address the global readiness questions, then you may have a different steps. It's not a simple thing to calculate right away. So therefore, and we realize, and we often have a kind of local readiness. It's called how ready is data to move to the next stage through the process that we consider. Okay? So then, and during this process, we start to calculate the difference local readiness. Then eventually, and we come up with the global readiness. A framework, and we proposed back to 2014 and last year. That's the first framework we proposed. We basically separate the process that typically NSC process involved. Is we have raw data, then we have signals, then we have plugged data, then come to the knowledge, then come to intelligence. Eventually, the NSC want to the data transform is kind of intelligence and to tracking or promote and national security at the United States. So this could treat it as local and readiness. So then we try to find a way to calculate each local readiness level. Then after that, we can combine this into a global DRL that's coming from different local states that depends the process you consider and the computation for each and local readiness will be different as well. But pretty much based on statistical approach. Next one, I want to mention a DoD project, and that's also a big data related. They don't have a big data, you call it big data program DoD, but it's a lot of programs, and they want to involve certain part of it in the big data aspect. It's called the community detection large networks. Basically, and as I mentioned in the previous Keynote talk as well, we have graphs, we have social network, we have a lot of physical networks, we have a lot of cyber physical and social networks nowadays. It's all connected, and a lot of networks that are useful for analysis for different aspects. But meanwhile, it's also create a problem. Okay, for example, last Friday we had a meeting with a colleague from College of Public Health. They actually built a lot of this top approach, built a lot of the networks called the disease networks. Okay, and using all different parameters that they consider from human perspective. Now, when the data become and the network become bigger and bigger, then the facing problem is too large, it's too complex, and it's really challenging for them to interpret for the networks. Okay, then and how do we handle this? Okay, and we come out a lot of different researchers also doing research in this field. Then we think and the community detection and could help. Okay. That's why we wrote the proposal to the Department of Defense and the community detection was approved. So basically, we consider two aspects in structure and function modeling of large and scale networks. Then we use the community detection approach, trying to identify the micro communities that we are considering. Okay? So when the network is small, you may not need this, but when the network becomes complex and big and huge, and then this are needed and not easy to find actually. So we also compared the approach and to the benchmark approach in this field, this BTR model and the CR model, to show the advantage of the model we have. So structural modeling and functional modeling for large scale network and modeling process. The research approach process, actually, we skip from the data to the network side, okay? But actually we have to build this. We have this tons of algorithm that should build from the original data and pure raw data to some kind of network structured data. And then we call it community networks. And once we have this type of data, this has become kind of source data right now we consider. Then we develop a different number of algorithms. We develop a number of algorithms in this field and to improve, gradually improve. So later on we will show at the best the results, the approach we proposed so far. Then we try to extract, based on the algorithm, we try to extract the micro and the communities and from this complex and the community networks. Okay? This is very useful, and for example, we can apply to Department of Defense or NSA. Okay, that's from defense perspective. They are related. Okay, they have a lot of data. Even you use approach, your traditional machine learning or classroom algorithm, build a networks. Network will be very complex. Okay, so for them, for example, if they try to obtain certain micro level local behaviors. And what's happening with Kaohsiung, for example, let's assume NSA can collect the Kaohsiung data, okay? So they have so much data, then they want to identify what kind of small community related any activities of Kaohsiung, right? They have to go to that detail level to identify. It's a challenge, okay? So that's requires, and different from traditional cluster and algorithm is, that requires you have to go deep to the very micro level so that you can identify very little networks, but it's very useful for you for this purpose. So this is a overall process, okay? And you can see this is a large-scale system or networks, and this is structure function analysis, and then this is called effect and development. This part is very useful, it's very important. This is computer science itself cannot solve the problem. We have to involve a lot of human factors, it's too small overall, and psychologists and a lot of different cognitive parameters have to play into this process. The more parameters you add it, the more complex, but potentially more useful to identify the aspect hidden. Then this is a database. They can synchronize from here if the certain effect that you manage, and for example, you have a new expert who have a cognitive science perspective, and the parameter from that directions, then the database will be changed and simultaneous as well. Then we have a visualization and after this process. So this is still going on because this was founded 2 years ago and not finished yet. So basically, and we can summarize this in which kind it is. You know, you have n vertices in the network or graph, and no peer information. Only know the X link connectivities and structure information. So how can you divide the network into a micro part, and so that you can find the interested communities that you're trying to find or you're trying to predict. So this is a very useful and information and research from the community detection in large networks. So we have a data center that's we created when I was still in North Carolina. So data center provides a lot of real data. This is all real data, okay? And the data that you can see from this website, there's a lot more at the bottom. And the student can actually come here to download data. Okay, and this is the free data we collected from all different real systems, and but it's open public. Okay, certain data is hidden, is because of privacy reason, and but this data that we show here is public. So for certain student trying to look for data for your research, and here you can go to ilabsite.org and come out a lot of data to download. So we apply our approach, our algorithm, to different and type of data, and that's we collected from the iLab data center. This is the U.S. football data, and this is the U.S. air flight data 1997. So that shows some results. Okay. So here you can see there's 6 different type of data sets was utilized for comparison the approach that we have with other different best markets. This is the benchmark approach, which means the community consider this is the best approach. If this is our approach, and we compare, it's called modularity Q comparison. You can see this modularity Q levels, ours is always better than any of the approach so far. Okay, what this means, the modularity Q is a measurement how micro you can go, how micro level you can go, which means how refined community you can find. Okay, so therefore, from the community detection from large network perspective, the larger the better. Even increase a little bit, then will help you quite a bit identify many micro level communities from large networks. Other project and I want to introduce is called DataBridge, and so DataBridge basically is a 3 university collaboration. Actually, collaborate with your university, then UNC Chapel Hill, and your side is Institute of Quantitative and Social Science. I think your slide also lists there for your collaboration. So then we have UNC Chapel Hill and us. Okay, so what's the DataBridge is trying to do is, well, the multi-way examples, we're talking big data, right? We're talking big data conference, big data research, and so on. But where the big data come from? Big data does not come from at once. And big data is coming from accumulation of small data. Okay, so a lot of small data in this field is more and followed called long tail data. And a lot of data is we found, and when we started and write these proposals, a lot of amount of data is actually atomistic and unconnected dark data. So we were trying to see, we have the social networks and Facebook and Twitter, all different social networks. And then we can imagine, can we build a social metric network for scientific data? So that is our original purpose we trying to build DataBridge. So this is overall design of DataBridge, and we still have almost 1 year left and for the project. So if you look at this, and IROC is contributed by UNC Chapel Hill, then DVN is data-first networks, and that's, I think, the art is a social science and networks applied by Harvard and Social Science Institute. Then we have a data metadata gathering, then we have tractors, then metadata ontology base. So this part is contributed by Harvard side, and a part of this as well. Then when they come to this side, it's called engine part. The DataBridge engine part is relevant engines and social metric analysis. So this is the part that we are leading. We are responsible for develop engine part. And after we develop engine part, we give this part to UNC Chapel Hill, and they are the building networks and do the visualization. So our part already done. I think the part of Harvard and side already done. So Chapel Hill is developing this part, is almost done, but in a prototype testing side right now. So I think maybe another several months, and we should have a version 1 released for public use. So it's very, very useful. And let me tell you what this approach is very useful. When we, back to 2012, and United States White House was inviting different researchers, industries, and White House folks in the government, and had a meeting talking about the big data directions, research so far and so on. So there, and so we together present idea of DataBridge, and actually a lot of industry people like it, and because it's very, very useful. Now, when we finish the project, the result will help you build this. Let's assume, and you at the bottom level, you have a lot of data from different domains. Then we build a layered networks. Okay, so at the bottom level, let's assume each data aspect is 1 node. Then next level will be 100 or 1,000. Next level will be 100. Next maybe 10. Then in extreme case, you can consider on top of this, I only have 1 node. Okay, this node represents all kinds of complex data I have in the bottom level, but with a lot of different parameters. Let's assume I'm interested in privacy research. Okay, now I look at the parameters related to privacy. Then I click the node, go to next level, then go to next level, go to next level. Eventually, I come to the bottom level. You know what? In order to address my research question, I only need to analyze this 3 or 5 data sets. Instead, I don't have to analyze all this data in the bottom level. So, advantages, you can save first, you can save a lot of computing powers, right? Second, even you have a supercomputing power to really analyze data, guess what? The result is full of noise, okay? Because you analyze the data maybe not quite relevant to the question you're trying to address. So Databricks can help you and alleviate the problem, okay? Cannot totally solve it, but can and help you to identify the interest data that's used to consider, okay? And also Databricks is running recursively, okay? You can run multiple times. It's not just one time. So next, I'd like to mention is called the network mining, okay? So anybody do data mining research? Data mining researcher. Okay, quite a bit, data mining, okay? We found it out when we started doing this difference and research. We realized we have to do the mining for networks, okay? Not only data, we do network mining. The reason for that, for example, was Professor Steele was talking about the graphs, right? You know, when you're talking about it become even simple is fine, but when you become very complex, then there's a lot of parameters that you have to consider. Those parameters can be treated as different features that you can consider when you transform into the structured database. So that is very, very useful. And so since I moved to UNLV, and we have a NSF App Score project and funded by National Science Foundation, basically gave a seed project, a high-risk project. You can try it out. So one of my postdocs was starting doing this type of research. We found this very useful. Other aspect we found is called network reduction, okay? And that's, we also have a different research publication going on, but need further research as well. So that also associates big complex networks. When we have small networks, we can visualize well and do a lot of things. But when they become very complex, then even visualization becomes impossible, okay? Therefore, we need a reduction. Major funding sources, and trying to show the appreciation for different major funding sources, and National Science Foundation, and Department of Defense, NSA, and NIH, and also quite a bit industries, but their funding level much smaller so far, and maybe the gaming company can pay more. So this helped quite a bit for different funding, and in past 3 years. This is also in the past 3 year visit. The current directions that we are working right now and need further development. One is we are developing is called data-intensive analytic platform. And so when I moved to UNLV and they have a supercomputer centers there, they said, you know what, we don't need it. We have a supercomputer centers really to deal with whatever data you have, okay? But the data-intensive analytic platform is different. Okay, it's different from traditional supercomputing platform. It's we hope this can incorporate data fusion from the different sources, and application of highways and reactive computing, and then persistent computations and real-time data streaming involved, and loosely coupled workflows, and integrate large batch, small batch computing. This is very important. So traditional supercomputer centers, and what they designed for? They designed for large batch computing, right? But nowadays, and how many data actually is produced from, for example, the small device, mobile phones, okay? Mobile device is actually a lot, right? Actually a lot. So those, and for the data-intensive computing, and which incorporate both large batch, the traditional supercomputing platform, and small batch computing for the data-intensive platform, okay? Then advanced instructions and facilitating the different virtual organizations can both handle supercomputing perspective and also the small devices. Another project we are starting doing is called Big Data Repository. As a requirement for Big Data Hub, then we want, but one of the objectives we want to build a Big Data Repository. This is very important. When I was doing research a long time ago as a graduate student, I think one of the challenges for me is finding data. Where especially real data. I come up maybe a lot of simulated data, but where the data come from, the real data come from, it's hard. Okay, it's hard. But when we're talking about different colleges, and for example, I call it public health, they actually have a lot of data collected from their field. They are waiting for a place to save there permanently, so that they can use it, because they don't want to save their local servers, those kind of stuff, because it occupies too much space. Okay, so therefore, this big data report is very useful. It's literally, we can share with all the researchers, and let's assume there's no privacy reason. Then that will be very, very valuable resources for the shared resource for research. Okay. Another aspect for the big data report, actually we have a group, is trying to develop a framework for privacy preserving and medical data sharing. And so that's actually part of the project related to the first speaker, especially for the medical field. And medical field, when they're doing this data privacy, typically consider, hey, whether this data is valid and follow the HIPAA or not. But follow the HIPAA does not mean you are not violating the privacy. Okay. So from our perspective, we try to develop more streets and the systems to help them protect the privacy and in the systems that we consider. Other directions that we already started doing this. This is a collaboration with started with the largest hospitals in North Carolina and Greensboro. Now we transferred to Las Vegas, and we already started talking about our medical school and also the local hospitals. It's built a virtual healthcare framework. Okay? So that is very important for United States. I don't know what's the healthcare system in Taiwan, but in US it's very important since Obamacare come out. And when I'm talking with the vice president of the hospital and ask them, they said traditionally in order to increase the revenue and for the hospital, what they do is hire more doctors and construct more buildings, more offices. So this is their way to increase the revenue. But it's very limited. It's very limited. So with this, virtual healthcare patient framework, it's, originally maybe one doctor can see 15 patients per day. Now they can say virtually and maybe 60 or more patients. So dramatically increase potential revenue the hospital can make. Okay? And another, and related this called, patient-centered medical, and this is an NIH COPA grant and 75 million and from the Nevada Institute of Personal Medicine and improve this. Another new project was announced the funding and last week, last Thursday, just before I left here, travel here. From Department of Energy and also National Oak Ridge Lab, and they have a best neutron spallation and technologies in the world. And a lot of people from the world, they come to National Oak Ridge Lab doing the research. So neutron spallation is very, very useful for material recognition, material analysis. And they have this neutron spallation images, and the image is much, much, much better than the image we can see, for example, hospital we take X-ray, much better than this. Okay? And their splitting speed is almost like 10 to the minus 5 to 6 and per round, and 1 round per second. So it's very huge, fast speed producing data. Okay? So this is very useful, but they do not have a good big data analytic platform and to utilize. So people from the world come to Oak Ridge Lab. Because they're hardware facilities, they use their materials to spell it and getting data. Then they have to come back to analyze in past, next several months. So what they need and collaborate with us to try and help them develop a very good big data analytics and software system so that they can analyze data in real time and for their systems. Okay. So this is still on time. Okay. And this is some directions that we try to help them to go, and it's also based on the network ideas. We have them in the first phase. This is a 5 years project. First phase, we try to build the material data networks, and for the material, the image data they're talking about. Then we try to build the object data networks on top of that. Then third phase, we try to build the universal data networks. Okay, 3 levels, and eventually we want to develop a universal data analytics for neutron spectrum analytics, and that they have. Okay, I think this is close to the final and it's almost there. Again, so I want to emphasize, and because it's a job that given by my team, so collaboration with the UNRWA, and the good aspect is not only financial sponsored by the gaming companies or hotel companies, and they have data. Okay, so in end of August, we had a conference at the Stanford University. So one of the group, they are hoping, they dream to collaborate with the casino company in Las Vegas for long years, but they have no way to gather data. And so when they say we are starting to collaborate with the casino and the companies in Las Vegas, they are so happy to collaborate with us, because through us, then they may get data. Okay, so that's another benefit that we can get the data from this. Okay, visiting professor, visiting scientist, graduate student, join the academic programs is all possible. All right, I think this is all my talk. Thank you so much.
Any questions? Okay, please.
So when you do this kind of community detection at many resolutions so that one can descend down, and also like in data bridge when you start from this high level and then able to descend down to some particular data sets, do any issues of overfitting or false discovery come that people need to be aware of when they're doing that?
Privacy.
And privacy as well.
For example, privacy. Oh yes, and that's certainly a big concern. I think the research you're doing is very useful, and so the privacy is always a concern. And for example, even right now, and I gave example the collaborative project with the National Security Agency, right? And I say, because security and privacy are already there, they can even disclose any original data to us at all, because national security policy there. But even for the casino data, for example, gaming data, and we are actually the legal teams right now signing the called the non-NDA, non-disclosure form. But beyond that, then we are starting a discussion what kind of data we can get from them. They have a slot machine data. That's basically people play the games. They can record all the games each person. Well, if we get the data, we can maybe improve the service for the casino company by personalized experience. Okay, so that's what we have. For example, I'm gambling, I'm doing this. Then if you could record all my resources and process, and also you record a lot of maybe similar players as me, then give me recommendations. I'm happy. You can recommend different ways. For example, you can do tricks that I can win a little bit more. Okay, even imagine I still lose, but you give me incentive to play more. Right? This is one way to improve. So that part is also involved the concern, sensitive, and privacy. So that's why the Stanford group, they are talking with a casino company at Las Vegas so many years. They couldn't get any data from them. The reason I think the big reason is a concern of sensitivity and privacy. Of course, I think back to a number of years ago, and big data is still not on the market. Then the casino company CEOs, they may not think about the big data. They think, why give data to Stanford? I don't need you. I'm doing very well. But now, because they are increased competitions around the world, for example, there's a lot of different casino companies in Macau and different places, then they have a more competitive and going on. Therefore, the smart CEOs, they started saying, well, if we can use our data wisely, then we actually can improve our revenue. That'd be great, let's do that. So they started talking about, but meanwhile, the customer data privacy is also, a concern. So I think eventually, what we gather data from them, that's why they want to cloud with us, because we locate the local. They feel more maybe safer or comfortable to disclose information to the local university of researchers. That's a lot of concerns. You're right. Any other questions?
Any questions? Any further question?
So there might be many different academic places, and the same customer may go to different places during the same holidays. Is it possible to get all this data from different companies?
That's very good. No, that's yes. The answer for that. The answer for that is yes. The reason for that is because nowadays the gaming companies, the casino company is merging. Okay, so right now I think the last year the largest company, so 2 years ago, the largest casino company in Las Vegas is called Sally. Okay, and last year Sally sold to ST, Scientific Game. So the trend is the larger gaming company starting merging all the smaller companies, and so therefore they become eventually one family. So in that way, it's very possible. Okay, but still, there's for example, if you're trying to get data from Las Vegas, meanwhile, if there's a different company like Macau, you're trying to get both data. If they are not have any relationship, then I think it's hard because they are competitors. I think it's hard. But Las Vegas, the trend is go to the one family.
Any further questions? If no any further question, before closing this session, I'd like to present you given an award.